It's kind of funny when you stop and think about it. Pretty much all the tech we use every day is built on this one-size-fits-all idea. I mean, the apps on your phone, the software on your laptop, they look and act the same for everybody. But what if they didn't have to? New research is showing how AI could just completely flip that script, creating digital experiences that adapt to you, and do it in real time.
So, here's the plan for this explainer. We're going to start by looking at why our digital world is so rigid in the first place. Then, we'll meet this really cool concept called the UI chameleon that's designed to fix it. We'll peek inside its AI brain, see how it actually did in testing, and finally, we'll dream a little about what a future with adaptive screens could look like. Sound good? Let's dive in. All right, first up, let's talk about these invisible barriers, the ones that are baked right into the tech we use every single day.
No, I mean, seriously, think about it. Your phone is this super powerful computer in your pocket, right? But the interface, it's totally static. The layout, the size of the buttons, how you tap and swipe, it's exactly the same for a teenager as it is for their grandparent. It's the same for someone with perfect vision as it is for someone who's visually impaired. It just doesn't change based on who you are, what you need, or even what you're doing right now.
And here's the thing. These might seem like tiny little design choices, but they create very real barriers. For a lot of us, okay, a tiny button is just a minor annoyance. You miss it, you tap again. But for someone with a motor impairment, that same button is a source of constant frustration. And low-contrast text? It can make an entire app completely unusable for someone with a visual impairment. Or think about this. A fixed way of interacting puts up a wall for anyone who needs to be hands-free, like a doctor in a sterile room.
Okay, so what if we just threw all that rigidity out the window? What if our interfaces could actually change and adapt to us right in the moment? Well, that question leads us to a really powerful new idea.
The concept is called an adaptive user interface. And look, we're not just talking about switching to Dart mode here. This is way bigger. We're talking about an interface that can intelligently, automatically change its layout, change its appearance, or even change how it behaves, all to make the experience more personal and inclusive for each and every single user.
And that's where this UI chameleon analogy really clicks. Try to picture your screen not as this static piece of glass, but as something, well, alive. It senses its environment. And that environment is you, and it instantly changes its colors, so to speak, to perfectly match what you need in that moment.
So, the big question is, how is this even possible? Well, the key, the real game changer here, is the technology powering it. Large language models, or LLMs. Yeah, the very same AI that's behind tools like Google Gemini. What makes them so special is that they're amazing at figuring out what we mean, not just what we say. They understand intent from all the messy, real-world stuff we do. A tap that misses the mark, a gesture that's a little shaky, or a voice command that's kind of garbled.
Okay, so that's the high-level idea. But how does this thing actually work under the hood? Let's dive in and take a look inside the smart brain of this system, a framework the researchers call Smart Intent Fusion. Basically, it's broken down into three pretty simple layers. Think of it like this. First, you've got the front end. That's just the app you're looking at. Its job is to capture whatever you do, a tap, a voice command, you name it. Then, that action goes to the input adapter. This thing is like a universal translator. It takes your input, whatever it is, and turns it into a standard language the system can understand. And finally, that translated info gets sent to the SEIF backend. This is the brain. It takes that input, combines it with what it knows about you from your profile, and makes the call on exactly how the interface should change to help you out.
But here's what's really clever. It's how this brain thinks. It's not all one thing. It's a hybrid. So for simple, predictable stuff, like you just barely missing a button, it uses fast, simple rules. You can think of that as the safety net. It's quick and reliable. But for the tricky stuff, the more complex or ambiguous commands, that's when it calls in the big guns, the creative spark of the LLM. By combining these two, you really get the best of both worlds. You get the lightning speed of rules and the deep intelligence of AI.
All right, so this all sounds great in theory, but did it actually work? Well, yeah. The researchers didn't just dream this up. They built a proof of concept and put it to the test. So let's see how it did.
Get ready for this number. In their tests, they found that a whopping 97.5% of all the interface changes the AI suggested were directly focused on making the app more accessible. Now, that is a huge deal. It means the AI wasn't just messing around, changing things for the sake of it. It was consistently and accurately proposing genuinely helpful adaptations, things like making buttons bigger or bumping up the text contrast to solve real-world accessibility problems. Now, the tests also uncovered a really interesting trade-off, basically speed versus perfection. With what they called a balanced setup, the AI came back with an answer in about 13 seconds, and it was about 85% accurate. But when they cranked it up to the heavy setting, it took longer, about 36 seconds, but the response was 100% accurate. What's cool about this is it means developers could tune the system. Do you need a pretty good answer right now, or a perfect answer in a little bit?
Okay, so let's zoom out. What does all of this actually mean for the future of tech? Well, the implications here they're way bigger than you might think.
I mean, the potential is just enormous. Imagine healthcare apps that literally adapt as a patient gets better, as their motor skills recover. Imagine truly hands-free tools for surgeons in an operating room. Or what about a car's infotainment system that automatically gets simpler and less distracting the second you hit a patch of bad weather? This isn't just about making one app better. This research is like laying the first cornerstone for technology that can completely redesign itself on the fly for every single person who uses it.
And that really leaves us with a huge question to chew on. For decades, we've built technology that serves us, that takes our commands. But this research points toward a future where just taking commands isn't going to be enough. So I'll leave you with this. What if our technology didn't just serve us, but what if it actually, truly understood us?